So,
but our teachers are best than his teachers.
really?
Except this. He goes fast, but for maths, their teacher is nice. For chemistry, their teacher is very nice. Arts, today also my chemistry sir told he'll cancel in the PD period. I want to see our views.
But the thing I love in KV is timings.
Yes, sir.
Very short and sweet.
Holidays, sir. Bunk school.
Yes.
Why? Ramesh sir told me to bunk weekly 3 days. But if I tell to my parents, they are not leaving.
No.
They are leaving only for 1 year.
Tell me, Rav, quickly I will explain. What do you want?
That gets that one.
Okay. Okay, 5 minutes I will explain to him till online students are. You want see, this is the current carrying solenoid, no?
Yes, sir.
This is the thing is used to magnetize all the substances.
Yes, sir.
Its turn density is small n and its current is I ampere. Yeah. What is the magnetic field at any particular point? Mu naught n into I, no? Now I fully filled with some soft iron or something.
Yes, sir.
So I can define completely I evacuated, no? I mean mu naught should not come.
Why, sir?
Because it is magnetizing this iron bar.
Yes, sir.
There is no vacuum now. So mu naught related to vacuum, no?
Yes,
So it should not come.
sir, the new we can put
So magnetizing field defined as total magnetic field per unit permeability is defined as magnetizing field. Tell me, what is the doubt? Magnetizing field.
This only, sir. How this came?
You want to magnetize soft iron bar, Arish.
Yes, sir.
You inserted.
Yes,
You
sir.
removed vacuum only now.
Yes, sir.
So I also divided with vacuum.
Sir, we have to we have took vacuum, sir. Then it would produce some. That medium would have some permeability, sir.
Yes.
That
This is, we want only magnetizing field, na? Magnetizing field means only magnetic field produced by the current carrying solenoid only, na? So I divided with the mu naught, that's all.
Yes, sir.
B value how much? Mu naught into n into I divided by mu naught. Mu naught cancels out. So n into I is the magnetizing field.
Yes, sir.
Understood?
Yes, sir.
And now, before magnetization of this soft iron, some atomic dipoles are clockwise, some are anti-clockwise. No?
Yes,
so net magnetic moment, how much?
0.
0. Once you kept inside the solenoid, what will happen? Because of the torque, all the dipoles will rotate in the clockwise only.
Yes, sir.
Now it will acquire some net magnetic moment. So net magnetic moment acquired divided by total volume of the iron bar is called magnetization. Magnetization. Now at this point P, how many magnetic fields are there?
2 magnetic fields. Sir.
2 magnetic fields. One is magnetic field due to solenoid. Other one is magnetic field due to soft iron. Soft iron also turned into magnet. Na?
Yes,
so net magnetic field, what I can write? Mu into H. Mu is the permeability of the soft iron.
Yes,
what a magnetic field due to only solenoid? Mu naught n into I. Na?
yes,
what a magnetic field due to soft iron bar? Mu naught into I. Na? Yes or no?
Yes, sir.
This is mu naught into capital H. Na? Plus mu naught. This is a soft iron bar turned into magnet, no?
Yes, sir.
So that is a magnetic field produced by its magnetization, mu naught into I.
Yes, sir.
Understood? So H you bring this side. H if you turn this side, what will happen? H I am dividing with on either side. Understood? You given magnetizing field some 10 ampere by meter cube. but it acquired some 1 ampere by meter cube only.
Yes, sir.
How much if you ready to give, but it should receive now. You want to magnetize for 10 ampere by meter cube,
Yes, sir.
but you magnetize up to 1 ampere by meter cube only. So 1 by 10 is nothing but susceptibility. This I by H is nothing but what here? Magnetic susceptibility of that soft iron bar.
Sir,
In your mind, you want to decide it to magnetic field H,
yes, sir.
but you failed. You magnetize up to I only.
Yes, sir.
In your mind, you want to magnetize up to 10 ampere by meter cube,
Yes, sir.
but you magnetize up to 1 ampere by meter cube only.
Sir,
So 1 by 10 is nothing but susceptibility. Tell me.
after that, even if you try a
You
lot,
cannot.
we cannot.
You cannot. Fish, if you train for running, can it run? No. It is not possible. It is against its nature.
Yes, sir.
Its saturation point is swimming only. It can swim only. No, I am a Usain Bolt. If you bring some millions of crores of money, if you invest, and will he train the fish? So you can't go against the nature. Understood? That's all.
Yes, sir.
No one came.
No one will come.
Okay, sir.
We are going to. So what happened to
Sir, when is our class, sir?
your class last
Your class, huh?
last Saturday? Last 12th lead, sir. Last.
Last.
Sir. Government with
Okay, I will start. Actually, why you have to struggle for them, I will explain to you. Okay. Anyway, 5:35 now. Okay, so let me introduce today. Pure resistive circuit. Pure which circuit? Resistive circuit with AC source. With which source? With the AC source. See here, I am taking one external resistance. How many ohms? Capital R ohm. And I connected to one source. I connected to one source of EMF. How much? E naught into sine of omega t. As I told you, AC generator EMF how much? Maximum EMF. E naught is nothing but what here? Peak EMF. Peak EMF or maximum EMF. Maximum EMF applied. But the omega is nothing but angular frequency. Angular frequency of AC current. Actually, students, one point I would like to mention. What is the difference between direct current and AC current? In direct current, the positive charges will completely having the translatory motion throughout the circuit like this. It is too risky, no? Correct or not? For example, in the labor work, some laborers has to transport bricks. What is the best way? One person has to lift some 50 bricks and he has to displace from one place to another place. He will be tired very quickly, no?
Yes, sir.
And he cannot work further. After 2-3 trips only, he is losing lots of amounts of energy. Instead of that, if 10 laborers are there, Instead of walking from there and there, I will make them like this. This is the smartest way only, na? They will stand like this, correct or not? Between A position and B position, and simply they will transport the bricks from one person to another person. It is the most effective way, no? Here you perfectly shifted the bricks from position A to position B, and these people, labor, the men will work for very long time now without getting tired. Why? They are just passing the bricks only. Says or no? They are not walking from one place to another place. So they are not getting tired very quickly. Are you understanding? So same concept we have to apply for AC current. What is AC current meaning? That positive charge will not transport from one place to another place. Just it will do the oscillation between left extreme position and right extreme position. At the right extreme position, when it is hitting with the other positive charge, what will happen? Tell me. It will transport its maximum kinetic energy to the other positive charge. So the other positive charge will go to next charge. So like that, only energy exchange only taking place. That positive charge will remain in the same position, but only energy exchange only happening. This is the best way of transporting electric current, na? Yes or no? That's what during the long distance transportation, which current you have to use? AC current only we have to use. Are you understanding? So I can define AC current as any problem, right? No one came.
The first class normally that. That's why maths are always we take first class and numerical.
AC current
It's
understood. So how will you define AC current? Transportation of which energy? Transportation of which energy? Electrical energy or kinetic energy? Electrical energy with only what here? With only oscillations of charge. Oscillations of charge is called what here? AC current. Okay. Now I am taking one pure resistor of capital R and connected to one AC source. What is the EMF of the AC source? E is equal to E naught into sine of omega t. I switched on the circuit. So tell me how much current is going in the circuit. Tell me. What the current flowing in the circuit formula? EMF across the resistance by resistance. No? Please say yes or no. What EMF across the resistance? E naught into sine of omega t divided by resistance capital R. Say yes or no. So what is the ratio of peak EMF by resistance? Peak current only, na? So I can write this is the peak current into sine of omega t. So peak current value how much here? Peak current is equal to how much? Peak EMF by total resistance of that. Tell me, this is nothing but phase of the current only, na? Omega t plus 0. And what is the phase of EMF also? Sine omega t plus 0 only, na? I mean, this is the current and EMF now I can treat like a rotating vectors or phasor. What is this? Current and EMF both are phasors. What is the concept of phasor here? Phasor is nothing but rotating vector. Rotating vector. Tell me now, what is the phase of the current? Please respond. What is the phase of the current? Phase of the current is nothing but omega into T, no? Omega into T. What is the phase of the EMF? Respond. What is the phase of the EMF? Also omega into T, no? What is the initial phase meaning? Please respond. What is the initial phase meaning? Initial phase. When time equal to 0, substitute what is the initial phase of the current? Put T value 0 here. What is initial phase? Also 0. What is the initial phase of the EMF? Put T value here 0. What is the initial phase of the EMF? Also 0. Initial phase means what? When time equal to 0. Now tell me, this is the x-axis and this is the y-axis. Tell me what is the EMF phasor? Initially EMF phasor is like this only, na? Why? Initial phase is 0. What is initial phase meaning? Please respond. What is the meaning of the initial phase? Meaning? Angle between. Initial phase is nothing but angle between or initial angle between. Initial angle between what and what? EMF vector and positive x-axis is called initial phase. And the length of this arrow is called peak EMF. Understood? So this vector is rotating with some angular speed. How much? Omega. What is omega here? Angular speed of the vector. Angular speed of the vector or phasor. Now tell me, after t seconds, what is the angular displacement traveled by this phasor? This is the x-axis. What is the angular displacement traveled? Tell me. Angular velocity into time taken only, na? Please say yes or no. This is the EMF phasor. And what is the peak value? E0. What is angular displacement? Omega into t. Say yes or no. What about the current phasor? Current phasor also how much? Omega into t, na? Understood or not understood? Along x-axis, initially current is also showing the x direction. After t seconds, it is rotating which direction? Anti-clockwise. That is omega into t. So this is the current phasor. Have you noted? Current phasor and EMF phasor both are in the same direction only, na? Correct or not? So you can represent like this. In single phasor diagram, if you take this as x-axis, this is which phasor? Current phasor. And this is which phasor? EMF phasor. And what is the angle between them? Omega into t. Zero. So phase difference between, I can write phase difference between current and EMF. How much? Current and EMF value how much here? Exactly 0. Understood or not understood? Both are in the same direction. What is the meaning of the same phase? Please respond. What is the meaning of the same phase? Meaning of the same phase. If EMF become maximum, current also become maximum. If EMF becomes 0, current also become 0. If EMF become negative maximum, current also become negative maximum. If EMF become minimum, current also become minimum. Is my point clear? So what is the meaning of both are in same phase meaning? Important note. Very important note. If current and EMF both are in same phase, what is the meaning of that same phase? If EMF become maximum, current also maximum. If EMF is getting 0, current also getting 0. If EMF is getting minimum, current also getting minimum. Is my point clear or not clear? That is the meaning of the same phase. Graphically also, if you see, this is a current phasor. How will you plot EMF phasor? EMF phasor also like this. Have you noticed? Current become maximum, EMF also maximum. Current becomes 0, EMF also 0. Current become negative, EMF also becoming negative. This is maximum, this is also maximum. This is 0, this is also 0. This is negative, this is also negative. This is a current phasor, and what is this? EMF phasor. This is current and EMF phasor. Tell me what is the current after t seconds? Current in the circuit, how much? I0 into sin omega t. Na? What is the applied EMF across the resistance? E0 into sin omega t. Now tell me what is the power dissipated across the resistance? Power dissipated across resistance, how much? Tell me. Power dissipated across resistance. How much? Power dissipated across resistance. What a power formula? Instantaneous EMF into instantaneous current. Yes or no? Substitute the value. E value how much? E0 into sin omega t into current into how much? Sin omega t. What is the power induced or power dissipated? E0 into I0 and sin square omega into t. Understood? This is a power dissipated across the resistance at what time? T seconds. What is the average value or average power dissipated? Tell me. Average power dissipated, how much? Average power dissipated. Average power is nothing but E0 into I0. And what is the average value of sin square omega t? Remember everyone, average value of sin square theta, how much? 1/2. Understood? And remember this thing also, average value of sin theta how much? 0. Average value of sin 2 theta also 0. Average value of 3 theta also 0. Average value of any sign how much? Upper half cycle plus negative half cycle divided by 2 only na. Upper half cycle plus 10 means negative half cycle minus 10. Its average value how much over a full cycle? 1/2.
Sir, no, sir. First, sir, it will have to upper half, right? Upper half, lower half, by 2. Lower half, instead of the lower half, only after 2 you have no. 2 half cycles you have.
2 half cycles. They are correct. Sin omega t, sin square omega t, na?
Yes.
No, if you still won't convince, integration of sin square omega t into dt. What is sin square omega t can be written as? 1 minus cosine 2 omega t divided by 2 into dt. Understood? Now integration of 1/2 into dt minus 1/2 into integration of cosine 2 omega t into dt. What integration of 1 by 2? 1 by 2 into capital T, full cycle, no? And what is the 1 by 2 integration of cosine 2 omega t? 0 only, na? If you have doubt, check it. Plus sine 2 omega divided by 2 omega. If you put the limits from 0 to capital T, you will be getting 0 only. Are you understanding? And divide by capital T, T cancels out half only, na? Please remember this all tricks, everyone. Average value of sine square theta. In fact, average value of cosine square theta also how much? 1 by 2 only. Are you understanding? In this max, I think you might be aware. If you are unaware also, now you are aware, na? So kindly remember this very valuable tricks. Understood? Now tell me, what is the average power dissipated across resistance? How much? E naught I naught by 2. This is the average power dissipated across the resistance. I can also write E naught by root 2 into I naught by root 2. What is the E naught by root 2 value? RMS value of EMF, na?
Yes,
Say
sir.
sir, no. So RMS value of EMF into RMS value of current. So the average power dissipated how much? ERMS and into IRMS. This is the total expression for what? Average power dissipated across the resistance. And some important key points you have to remember. Very important key points you have to remember. Current phasor in acting in which direction? EMF also acting in the same direction. In fact, resistance also acting in the same direction. All are in the same phase only. Is my point very clear? Understood or not understood?
Yes, sir.
Okay. Now let me introduce very immediately pure inductive circuit. Pure inductive circuit. Pure inductive circuit with an AC source. With an which source? AC source. So I am taking one coefficient of self-inductance L Henry and I am connecting to what? Please respond. I am connecting to one EMF source or AC source. What is EMF at any time t seconds? E naught into sine omega t. At a particular instant of time, I will assume this is positive half cycle, this is negative half cycle. How current will go? High potential to low potential. I will walk from A to B, then B to A. I am walking from A to B, then B to A. When I am walking from A to B, what is the voltage drop induced across inductor? Tell me. I am walking from high to low potential, na? I should write minus or plus. I am walking from high potential to low potential. Potential will increase or decrease? Decrease. So minus L into dI by dt. According to Faraday's law of electromagnetic induction, what is the EMF induced across the inductor? Minus L into dI by dt. Then where to where I am entering? B to A. Low to high I am entering. Potential will increase or decrease? Will increase. So plus I am keeping. What is the voltage drop across the source? E naught into sine omega t is equal to how much? 0. Correct or wrong? So I can write L into dI by dt is equal to E naught into how much? Sine omega into t. All time terms, I mean t and dt, I will write one side, and current terms, I will write another side. So what I can write? L into di is equal to E naught into how much? Sine omega t into dt. I will integrate on either side. What integration of 1 into di? Tell me. I into L. And what is integration of sine omega t? Very good. Minus cosine omega t and divide by omega, na? In the denominator, omega t, you have to differentiate it. Please say yes or no. d by dt of omega into t. Correct or wrong? So you can write L into I is equal to minus E naught into cosine omega t whole divided by omega into how much? Dt by dt. Dt cancels out. L value bring this side. So what is the current after t seconds? Minus E naught divided by omega into L into cosine omega into t. Understood? So I can write minus cosine omega t. What I can write? E naught by omega L into how much? Minus cosine omega t. Current equal to how much? Always the denominator term is representing what? Resistance only, na? Correct or not? But you should not call resistance. That is called opposition given by inductor. That is called reactance, inductive reactance. That is denoted with the symbol XL. XL is called what here? Inductive reactance. Inductive reactance. What is the concept of reactance? When original current is increasing in the circuit, but because of the inductance, it will try to oppose that. That opposition given by inductor to decrease the original current in the circuit is called what here? Inductive reactance. Understood or not? What is the reactance meaning? If original flux is increasing, it will try to decrease it. If original flux is decreasing means it will try to increase. That opposition behavior only called what here? Inductive reactance. What is the inductive reactance value? Omega into L. Everyone compulsory should remember at your fingertips. And also minus cosine omega t, what I can write? Sine omega t minus 90 I can write now. Please say yes or no. If you have doubt, check it out. Sine 90 minus omega t means what? Minus cosine omega t only, na? Correct or not? Means if you notice this, how much EMF you applied? Sine omega t. But how much current you are obtained in the circuit? This ratio of peak EMF by reactance is nothing but peak value of current only, na?
Yes, sir.
That is how much? Sine omega t minus 90 degree. I mean current is leading or lagging? Lagging by how many degree? 90 degree here. I will write down that point. If inductor dominant circuit, if in circuit inductor is dominant, inductor is dominant, current is lagged by how many degree? Current is lagged by how many degree? Lagged by 90 degrees. That point everyone have to remember at your fingertips. I mean, how do you plot the graph? This is a EMF phasor. EMF phasor with x-axis, how much angle it is making? 0 degree, na? Omega t plus 0 meaning with x-axis it is making 0 degree. What about the current phasor? Tell me. Lagged by 90 degree, na? Means this is the current phasor. Lagging means clockwise angle 90 degree. Understood or not understood? Okay. So that is the phasor diagram between, or phasor diagram. This is called phasor diagram between what and what? Between EMF and current. Understood everyone? What is the average power dissipated or power dissipated? Respond. What is the power dissipated formula? Power dissipated how much? EMF induced into current induced. What is EMF induced value? E naught sine omega t. What is the current induced value? Respond. What is the current induced value? Minus I naught into cosine omega t, na? This value I am writing, students. This value I am writing. So I can write minus E naught into I naught into how much sine omega t into cosine omega t. This is the power dissipated at any time t seconds. Slightly I will divide with 2 and I will multiply with 2. So what will happen? Minus E naught I naught by 2. 2 sine A cosine A wale how much? Sine 2 omega t na. This is the power dissipated at what time? T seconds. Now I want average power dissipated. I want average power dissipated. Average power dissipated. How do you find? Tell me average power dissipated. Average power dissipated is nothing but minus E naught I naught by 2 into. I told you just now what is the average value of sine 2 omega t? 0. Upper half cycle plus negative half cycle by 2, no? Upper half cycle plus negative half cycle divided by 2. How much? 0 by 2 only, na? Correct or not? Many times I told average value of sine theta how much? Not only sine theta, sine 2 theta, cosine 2 theta, sine 3 theta, everything is 0. So what is the average power dissipated? 0. Why 0? Logically you can understand. There is no resistance now. Pure inductor does not have any resistance. As there is no resistance, there is no power dissipation. Is my point clear, everyone? I'll write down that point. As there is no resistance. As there is no resistance. As there is no resistance for pure inductor. As there is no resistance for pure inductor, no power will dissipate. No power will dissipate. That is a power dissipation. Now pure resistance over pure inductor over what's up next? Pure capacitor. In the name only it is there. What is the meaning of pure capacitor? Without any resistor. But it is ideal case only, na? Correct or not? Every capacitor plate is made of metal. Metal, less or more, it is having some internal resistance only, na? This is or no. So it is called ideal capacitor. So I am taking one pure capacitor of capacitance how much? C microfarad and connected to one AC source. What is AC source of EMF? E naught into how much? Sine of omega t. For example, at any particular instant, this is a high potential and this is what? Low potential. How current will go? From high potential to low potential only, na? I will assume this is A to B, then B to A. A to B and B to A. I will apply loop law. Tell me what is the loop law? When you are walking from A to B, high potential to low potential you are walking. So potential will decrease or increase? Will decrease. What is the potential drop across capacitance? Tell me. I'll assume this charge is Q. So Q divided by C. Then I am entering from low to high, means plus E naught into how much? Sine omega t. Equal to how much? 0. So Q by C is equal to how much? E naught into sine omega t. What is the charge on the capacitor after t seconds? C into E naught into sine omega t. I want current after t seconds. How will you find current? Increment in charge on capacitor in 1 second only, na? So substitute here. Current in the circuit, how much? D by dt of Q value, how much? C into epsilon naught into sine omega t. C into epsilon naught I will take it outside. But integration of the differentiation of sine omega t, cosine omega t, and d by dt of omega into t. So current equal to how much? C into epsilon naught into cosine omega t into a differentiation of omega into t, omega into dt by dt. dt cancels out. So what is current after t seconds? Epsilon naught whole divided by 1 by omega into c I can write now. Please say yes or no. Cosine omega t, what I can write? Omega t plus 90 I can write now. What is the denominator value representing? Opposition given by capacitance while charge is growing. Correct or not? While charge is growing, the existed charges do not like it. Existed charges repelling the freshly arriving charges na. That opposition is called as capacitive reactance. How will you represent the capacitive reactance? XC. X is nothing but what here? Capacitive reactance. Capacitive reactance value how much? 1 by omega into C. You should remember at your fingertips. And if capacitor is dominant, current is leading or lagging? You are applying EMF how much? E naught into sin omega t. But what is the current in the circuit? Tell me. Leading only, na? The ratio of peak EMF by capacitive reactance is nothing but peak current. And into how much? Sin omega t plus 90 degree. So one very important note. One very important note. Because of the capacitance, current is leader or lagger? Current is lagger only, na? So current is leader only, na? So in the presence of capacitance, very important note. In the presence of capacitance, current, what will happen? Current leads by how many degree? 90 degree. If you see the phasor diagram, this is a EMF phasor, na, E naught, and current is leader or lagger? Current is leader by how many degree? 90 degree. This is a current versus EMF phasor. What is the power dissipated formula? Instantaneous EMF and into current value. But instantaneous EMF E naught into sin omega t and into what is the current instantaneous current? How much? I naught into cosine omega t, na? Yes or no? Here straight line I am using this cosine omega t. And there's no issue, no? Correct or wrong? So I will multiply with 2 and I will divide with 2. What is the power dissipated? E naught I naught by 2 and 2 sin omega t into cosine omega t, how much? Sin 2 omega t. Yes or no? I want average power dissipated. What is average power dissipated value? Tell me what is average sin 2 omega t value? 0 only, na? So here also how much average power dissipated? 0. Is my point clear? Okay. Thank you, students. Thank you, students. Thank you. Bye.